All right, let's jump right in. We're about to unpack a story you probably don't know. How a website made for poking your friends accidentally ended up building the instruction manual for the modern internet. It's a wild story of insane scale, things constantly breaking, and, well, accidental genius. And this quote right here, it absolutely nails it. This is the whole idea. We're talking about technologies that you've probably heard of, things like React, GraphQL, tools that weren't built for the world. They were built for Facebook's own survival. And in doing that, they basically changed everything. You see, as Facebook just exploded from a dorm room project into this global monster, it kept running into engineering problems that nobody had ever even seen before, let alone solved. So in the process of just fixing its own stuff, it ended up creating the very protocols and frameworks that now power so many of the apps you use every day. So let's start with the first huge problem they hit: connection. I mean, how on earth do you make a platform with billions of users feel like a tiny, close-knit group where every single update happens in a flash? Just think about your newsfeed for a second. Every single time a friend posts something, you leave a comment, or someone likes a photo, that little update has to get to potentially thousands of people, like right now. At the scale Facebook was operating, doing that with the old tech was not just difficult, it was basically impossible. So their solution was this super clever system they called a fan-out strategy. It was a beautiful mix of two different techniques, push and pull. So think of it like this. For you and me, when a friend posts, that update gets pushed to our feed right away. But what about a celebrity with millions of followers? Pushing an update to all of them at once would just melt the servers. So instead, when you go to their profile, your phone pulls their latest updates just for you. It's such a smart way to handle a totally insane amount of traffic. And an idea this good? It definitely didn't stay inside Facebook. Twitter uses this exact logic to pump out 500 million tweets a day. It's the secret sauce behind your WhatsApp group chats feeling instant. It's even what keeps the game worlds in Roblox in sync and pushes data from massive machines on factory floors. And just to help you wrap your head around the scale here, WhatsApp by itself delivers over 100 billion, that's billion with a B, messages every single day using this core idea. It's just a mind-boggling number, and it's all built on a system that was first designed just to make the newsfeed not crash. But just sending updates is only one piece of the puzzle. You also have to understand how all the pieces are connected. And that's where this system called Tau comes in. Think of Tau as Facebook's digital brain. It's not a simple database. It's a living map of all the relationships, connecting you to your friends, to the photos you're tagged in, to the places you check into. And the effects of this are just everywhere now. The very same logic that figures out who Facebook should suggest as your next friend is what LinkedIn uses to find your next professional connection and what Tinder uses to find you a match in literally milliseconds. The social graph is the invisible engine behind so much of our digital lives. Okay, so let's move on to the next monumental challenge: data. And I don't mean just a lot of data. I mean, how do you store an almost unimaginable ocean of content that's being created by billions of people every single day? Let's make this real with something we all get: uploading photos. Back in the day, trying to store billions of little individual photo files was just a total nightmare for computer file systems. And trying to find and load one of them quickly, even harder. Facebook's solution was a system called Haystack, and the idea behind it was just brilliantly simple. Instead of trying to manage billions of tiny little files, Haystack just bundles thousands of photos together into these giant single files. They call them blocks. This slashed the amount of extra data needed and made finding that one photo in a haystack of billions way, way faster, like up to 10 times faster. So get this, today, Meta's systems, which are still based on these original haystack principles, are delivering around 550,000 images every single second. That's the kind of speed you need to make Instagram and Facebook feel instantaneous. And just like their other innovations, this idea spread like wildfire. A similar system is what Twitch uses to store all those video thumbnails you see. It's what Shopify uses to serve up product images for nearly 2 million online stores. And the lessons they learned help shape other huge data technologies like Cassandra and Hadoop that now run everything from your Spotify playlists to Airbnb's pricing engine. All right, so we've got connection handled and we've figured out data storage. The third and final challenge is all about performance. How do you take this unbelievably complex, data-heavy app and make it feel light, responsive, and just fast? Every single time you open an app, it has to talk to a server and ask for data. And believe it or not, the way it asks is the difference between an app that feels instant and one that feels clunky and just makes you want to close it. It all comes down to the API problem.
So the old way of doing this was just not great. The server would just send this giant one-size-fits-all chunk of data, and your phone's app would have to pick through it to find what it actually needed. This is called overfetching. So Facebook invented GraphQL, which just flipped the whole thing on its head. Now, the app tells the server exactly what data it needs. No more, no less. It's like going to a restaurant and ordering exactly what you want instead of having them bring the entire buffet to your table. Just one perfect request and one perfect answer.
And yeah, as you can probably guess, GraphQL basically became the new industry standard. It's what GitHub uses for its entire developer platform, it's how Shopify makes product searches feel so quick, and it's how the New York Times gets you breaking news in a snap. But GraphQL was really just one part of a much bigger revolution in how we build the front end of apps. It started with React, which let developers build interfaces out of these reusable bits, kind of like Lego blocks. Then they created something called Flux, which made sure data moved through the app in a simple, predictable way, which prevented all sorts of chaos. And finally, Relay was the glue that connected those React components right to GraphQL. The whole thing was a seamless, high-performance machine. So when you pull it all together, when you really step back and look at the whole picture, you see this incredible, unintended legacy. Facebook was never trying to build a toolbox for the rest of the internet. It was just desperately trying to keep its own website online. This quote right here just says it all. The insane pressure of their scale forced them to invent things. Every time the site went down, it wasn't just a disaster, it was a crash course in how to build things stronger, faster, and better for the next time. And here's the kicker. Because Facebook made so many of these tools open source, meaning they just gave them away for free, their internal fixes became the public blueprint for the next generation of the web. They didn't just solve their own problems, they ended up giving everybody else the answers too. So here's what you should really walk away with. First, huge, massive problems force you to find radical new solutions. Second, sharing those solutions can literally change the world for an entire industry. And finally, that smooth, fast experience you get on so many of your favorite apps, it's standing on the shoulders of Facebook's chaotic, decade-long struggle just to stay afloat. And all this leaves us with one last big question. If Facebook's problems trying to scale built the web we use today, what are the crazy internal problems being solved right now, in secret, at companies working on AI or virtual reality or decentralized tech that are going to become the foundations of the internet we'll be using tomorrow?